Welcome, Hornets. Today we're going to take a look, or in this section, we're going to be taking a look at solving exponential growth and logarithmic functions, specifically by exponentiation. The process of exponentiation is the process of creating exponents. Logarithms are exponents, and obviously functions with exponents have exponents. So let's just take a quick peek and see what we're talking about. Something to the effect of 7 equals e to the x plus 1. So if I'm looking at a problem like this, the first thing I have to recognize is I have to make the exponent, which is an x, into a base. The way we do this is exponentiation. I'm going to use the natural log, and I'm going to take it to both sides. And you'll notice it gives me the natural log of 7 equals natural log of e to the x plus 1. According to my properties, the power moves in front. X plus 1, natural log of e, equals the natural log of 7. Now, we already know that the natural log of e is 1, but I'm going to continue going just so that we can see what's happening. So we're going to distribute the natural log of e first. So the natural log of 7 equals x natural log of e plus the natural log of e. I'm now going to subtract the natural log of 7 minus the natural log of e equals x natural log of e. A minus represents the fraction, so I'm now looking at 7 divided by e equals x. Notice the natural log of e equaling 1 is now going to be applied to this to make my problem easier. This then is my answer. Now, in the problem that we were looking at a moment ago, we had a fairly complex one. And the problem was 7 power 4 times 3 to the power of x equals 5 to the power of x times 6 squared. Now, what we're going to do is we're going to have to work with this following our laws of logarithms in order to make this work for us. So the first thing we're going to do is we're going to take the natural log on both sides. Now, we can use log base 10, we can use natural log, we can use any base we want. I'm going to use base e. I find it easier to work with, and as a mathematician, I like to be minimal, and I'm avoiding one letter. Okay, so instead of LOG, I have LN. It's one letter less. I'm now going to apply the first property that says a product is a sum. Natural log of 7 to the 4th plus the natural log of 3 to the power of x equals the natural log of 5 to the power of x plus the natural log of 6 squared. Now, because the powers move in front, we have 4 natural log 7 plus x natural log 3 equals x natural log 5 plus 2 natural log 6. We now start to condense and get our values of x to the same side. So I'm going to subtract x natural log 5. I'm also going to move that 4 natural log 7 to the right. So I have x natural log 3 minus x natural log 5 equals 2 natural log 6 minus 4 natural log 7. Factoring out my x, leaving me with the natural log of 3 minus the natural log of 5, having 2 natural log 6 minus 4 natural log 7. And I'm now just going to divide. So this denominator becomes this piece here and goes away. And I now have the natural log of 3 minus the natural log of 5. This is my solution. This is what we're looking for when we do these problems. Now, it doesn't matter whether I use base 10 or base e. My goal here is to ensure that I have a common base regardless. So as long as I take the same base on the right and the left, I'm going to be okay. And that includes non-standard bases like base 4, base 10, non-standard, excuse me, base 7, whatever it might be. Okay, let's take a look at one more, and then we're going to go ahead and end. And this is working with solving the logarithms. Now, logarithms, just like the exponentials, require exponentiation. And this is going to be the reverse process that we work with. So you'll notice if I have a natural log, I want to get rid of that natural log, so I'm going to exponentiate. See how it became an exponent? E to the 5th. According to my rules, e to the natural log of a is simply a, and therefore I'm looking at 2x minus 3. I'm now going to add 3 to both sides. 2x equals e to the 5th plus 3, and then dividing by 2 gives me my solution. X is e to the 5th plus 3 divided by 2. Once again, this process is called exponentiation, and it's how we are finding our x-intercepts. Now, we will be finding that x-intercepts are very important to us in calculus, along with y-intercepts, so that's one of the reasons why we find them. Thank you very much. Be well, Hornets. Take care.